My name is Rebecca Jones and I study aerospace engineering at Queen's University Belfast. As part of our STEM outreach goal, we wanted to help give an insight into what it's like to study aerospace and show you behind the scenes of a special project we've been working on all year. First of all, let me share with you the basics of the course. Entry requirements usually state you need A-level maths and physics or a foundation degree, but you can check the up-to-date requirements on the QUB website for the year you'll be applying. The bachelor's degree is 3 years long, and then you can add another year for placement and another year to make your degree a master's, depending on your preference. 5 years isn't too bad to be a rocket scientist.
In the first year of the course, you will cover all the basics you need to go forward and have a whole module focusing on your introduction to aerospace engineering. So don't worry, you don't need to be an expert in aircraft before starting. We are all beginners at one point. In second year, it becomes even more aerospace focused, and along with your basic modules like maths, you learn about aircraft aerodynamics and performance, supersonic flow and propulsion, and aircraft structures. One of the most popular modules of second year is called Flight Laboratory. During this module, every student gets the opportunity to fly in small groups with the Cranfield University National Flying Laboratory Centre. While in the air, you carry out a series of experiments on the stability and control of an aircraft as the plane manoeuvres in the skies above Belfast. This allows you to have first-hand experience of fundamentals of flight that you'll have only studied theoretically before. During the flight, you will characterise an aircraft in the same way that new designs are assessed by test pilots. Another exciting module in second year is called Aircraft Design. This is a group work project where you literally design a whole plane based on a brief. This could be a fighter plane or a large commercial plane or many other cool configurations. This task uses your knowledge from all modules and most importantly is a lot of fun.
So that brings us on to the special project mentioned earlier. In year 3 of the course, you will undertake another aircraft design module where this time not only do you get the opportunity to design the plane, but you actually get to build and fly it as part of a team. We have all just finished third year and are currently preparing to travel to England to represent Queen's and take part in the IMechE or Institute of Mechanical Engineers UAS competition, where we will be competing against many other universities from around the world. Our aircraft is an unmanned aerial vehicle with a maximum takeoff weight of 10 kilograms, and it is designed to undertake various different mission requirements, such as area search, navigating waypoints, accurately dropping an aid package, and returning to base via a defined route. Our team is called Team Anthus, and we have 11 different members. Each member is responsible for a different element of the aircraft. The roles and departments within the team include structures, aerodynamics, avionics, image recognition, manufacturing, propulsion, CAD or computer-aided design, weight and balance, landing gear, and stability and control, which is the department which I was actually in charge of.
We spent the first half of the year, from September to December, designing the plane. We had a preliminary design review in October where we presented our initial ideas to the lecturers and received some great feedback to integrate into our design. The final design was then locked in at the critical design review in December, allowing us to start building the UAS in January. Our aim was to build an aircraft that could take off and land in as short a distance as possible, be as lightweight as possible, and to drop a payload onto a target. All these aims align with the need for humanitarian aid. The aircraft is built completely from scratch with some help from the Queen's workshop and technicians. It took 3 months of manufacturing before we could take it for its first test flight. Test flights are important as it allows us to see any errors which we can fix before the competition. For example, the wings in our aircraft were not exactly symmetrical, which meant the aircraft could only turn left. We were able to catch this and fix the issue early on, and the plane now flies perfectly. Here are some photos and videos of the making of our aircraft, showing the evolution from an idea on paper to a real-life aircraft taking off for the first time.
insight into aerospace engineering has inspired some of you to consider a future career in this very exciting industry. If you would like to see how our aircraft gets on at the IMEC Geek competition or have any other questions for us, you can follow us on Instagram, Facebook or TikTok at the following tags. Thank you for watching!